So 3 compounds left, 1, 2, 3, an acid and 2 esters, and 3 spectra left. Now, all 3 of these compounds, being the acid or the esters, have got this nice downfield peak here that corresponds to that carbon that's bonded with 2 oxygen atoms. So that's not going to help us at all. All of them have got 4 distinct carbon signals. That's a very far downfield signal, and then 1, 2, 3, 1, 2, 3, and 1, 2, 3. So that's not going to help us at all. So what can we look at to get a bit of a handle on this? And the first thing that I would do is I would say, look at what we've already used several times before, the peak for a carbon bonded to an oxygen that's taking place somewhere between 50 and 70 or 80. Because if we look at these, the acid, obviously it's got carbon 4 that's bristling with oxygens, but none of carbon 1, 2, 3 are bonded to oxygens. However, in this ester, carbon 3 bonds to an oxygen, and in this ester, carbon 4 bonds to an oxygen. So let's see if there is a spectrum that doesn't have an obvious carbon bonded to an oxygen. Look at C2, that's the area where we'd expect it, it's not there. C5 right there at about 52, and C3 right there at about 60. So that enables one to unambiguously assign spectrum C2 as being butanoic acid. Now let's quickly go through and assign which carbons they are. Obviously this one up here is the acidic carbon, C4, and then as we march away from that acidic carbon, C3, C2, C1, we of course get further away from the nasty electronegative atoms, so I would expect a little progression, going C3 is the next one, and then C2, and then C1. Okay, so C2, this acid here, without much doubt. Now let's look at these other 2 esters, and you might remember from when we were dealing with the hydrogens that because you've got a methyl and an ethyl and an ethyl and a methyl group, this doesn't exactly lend itself to a very easy assignment. And indeed, the best thing that I can come up with to help us do this assignment is just to remember that when you have a methyl group or a CH2 group, almost always, unless there's something else messing around with it, the CH2 group is a little bit further downfield than the CH3 group, mainly because the CH3 group is a carbon bonded to 3 hydrogens and another carbon. The CH2 group has got, instead of 3 hydrogens, 2 hydrogens and a carbon replacing that hydrogen there. And of course carbon a teeny bit more electronegative than hydrogen, so therefore the CH2 will come more downfield than the CH3. Now if we look at our carbon bonded to the oxygen, in that case that's the C3 here, which is CH2, or here it's the C4, the CH3, we can see that while they're both at the peaks appear within the appropriate range, in C5 it's at about 52 or so, in C3 it's at about 60. So the further downfield one here, the 60, I would say is the oxygen CH2, and this one that's a little bit further upfield is the oxygen CH3. So in other words, I'm going to move this one there and this one there. Let's click that, shall we? There's that one becoming C3 and this one becoming C5. Let's go and assign the carbons and see if there's anything that rings untrue about that. In C5, of course, this is obviously the C3, the ester carbon. The next one down is going to be C4, the carbon bonded to the oxygen. And now we have C2 and C1 again, because as you go C2, C1, you're getting further away from all the electronegative action. So C2 there, C1 there. Now let's do the same thing for our assignment of C3. Again, very far downfield peak will be the ester one, which in this case is C2. The oxygen bonding to C3 right there, so that's the C3. And then of these ones here, I would imagine that C1 is the one closest to all the electronegative actions, so I'd say that one's C1, and that one is C4. Now again, just to close off by repeating the argument that I used back with the carbon bonded to the oxygen, okay? When we look at the, for example, CH2 here, versus the CH2 there, of course we see that this is the one bonded to the oxygen. If we look at the carbon bonded to the bristling oxygen one, so in this case that's C2, which is about 28, and in this case this is C1, which is about 20. And again what we see is that the CH2 is further downfield than the CH3 in otherwise equivalent situations. Again, looking at the carbon that's bonded to the ester carbon, CH2 here, closer to 30, CH3 here, closer to 20. Okay, so I'm fairly confident with my C3 and my C5 assignments just based on comparing a typical behavior of CH3 and CH2. So let's celebrate by concluding both the proton and the carbon assignments there. Definitely a fun little assignment for you. Hopefully you understood it. I would have said that's about as sneaky as you're going to get with NMR assignments for quite a while, if not your entire university career.